Hey there, bouncers. It's come to my attention you all like the technical stuff. So I guess you asked for it. Let's check out the Code of Bouncy Boy.
You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes.
But before we do, I want to just quickly mention how important it is to see past your prototype of the game. What I mean by that is, it's very important to prototype a base idea and see if it works and if it's fun, but it's also very easy just to give up on that idea before seeing it through to its final form. So let's see what Bouncy Boy looked like then versus what it looks like now. Saving and loading data. Before I got the approval to release Bouncy Boy on consoles, I had a pretty simple save system implemented. It was pretty similar to the thousands of videos that you see on YouTube about how to save and load data. However, once I saw the requirements for disk access for consoles, I had to change this in a pretty big way. Of course, there's not a lot I can talk about for the console development due to NDAs and such, but I can say this. I had to save my change methods to using chunks of bytes rather than just sending it to the binary formatter and calling it a day. Because I am saving to 3 different platforms, Switch, Xbox and PC, I decided to make a save manager, which the game calls when saving or loading data. It will then call the targeted platform save class to do all of the platform specific instructions. The layout of this concept looks like this. The wrapper Save Manager class has public methods such as initialize, save, and load. Using platform-defined directives, the Save Manager will call the respective save class method. This will either take or return the same data across all 3 platforms, but the way that they are written and read from storage differs depending on the platform. All of these tasks are asynchronous and have a whole heap of checks to ensure that the data is read and written correctly. Speaking of which, this leads into the next topic. Bouncy Boy uses async await methods extensively. As just previously mentioned, all the save and load commands are asynchronous, but another way I use C# async await is for creating sequences such as this one. Let's break down exactly what is happening with this effect. First, Spook Sister determines if there's a valid tile that can be used for the summon. The player is then blocked from movement, a rumble pattern is sent to the gamepad, a spotlight appears over Spook Sister and some particles start playing. The screen dims over 1 second, then Spook Sister starts her summon animation. The sequence is paused until this is done. The Skelly Hand is then summoned, Spook Sister's animation controller then goes back to an idle state. The player can now move again, the spotlight is turned off, the particles have now been stopped, and finally the screen brightness is returned back to normal. Having the ability to have one method control this sequence, rather than dealing with many checks in the update loop or going through that callback hell, it just makes designing these kinds of sequences an absolute pleasure. Another thing I use async await functionality with is waiting for the player to press a UI button. For example, there are times in the game where the player will get trapped by an opponent and cannot move. The game will check if the player is able to move, and if it's determined they cannot, a UI prompt will display with a message, and an action button is shown to the player. The method that handles this will show the UI message, and once the player has pressed the button, it will continue on with whatever action is needed. In this case, it's reloading the level. Another cool thing to know is you can have an async method return a value, which you can't do with a coroutine. I use this sometimes to return a success value, or in the case of loading the save game, the data. Coroutines still have their place, however. This Unite talk here will go deeper into explaining the pros and cons of both in pretty high detail. I have a developer secret about Bouncy Boy. I don't have update methods in my codebase.
It can't be true, it can't be true!
Yep, that's true. There's no script in my codebase that uses the update loop. So how is this done? Let's all welcome DoTween to the party.
Welcome to the party!
DoTween is a tweening library which is super performant and plugs into just about every major component in Unity. If there's not a built-in extension for a component that you want tweened, it also has this concept of a virtual tween, which allows you to tween a float and shove that value into whatever component you like. One of the biggest wins for me is that it's awaitable. So extending what I was just talking about in the last section, I'm able to use the tweeners in a sequence and await for their completion. That is super cool.
Or cool and sexy.
Tweens have been used in Bouncy Boy from anything such as making UI bounce and squish, through to making the player and opponents move. I have this concept of a one-shot particle. What this basically means is a particle effect which is momentary, normally a burst, and it may be used by various objects or various object types. For performance and optimization reasons, I didn't want to have a prefab for this particle effect and then just simply throw it onto every object that would use it, potentially having multiple copies of the same thing in the scene, and most of them being inactive. So what I have done is kind of make like a pooler manager for these particle systems, and then have them simply play via a command. The manager is a simple scriptable object which holds a reference to the particles being used and loads them into memory on boot. They are kept persistent throughout the game. They're also using the addressable assets, which you can see here. This topic can get a little complicated and is probably worth its own episode down the line. So when I need to fire off a particle, I simply need to just call Game Manager, Persistent Particles, Spawn, pass in the ID of the particle, the world location to spawn it, and optionally the rotation. And there we go. Another episode done and dusted. Thanks for hanging about and being part of the community. The next episode I'll be going over the sound and music integration of Bouncy Boy, which has been quite interesting, so I think you guys will love it. I'll see you next time.